Every single day we see these incredible leaps in technology, right? From mind-bending AIR to major breakthroughs in scientific research, it really feels like we're living in the future. But have you ever just stopped for a second and wondered what's actually powering all this progress behind the scenes? Well, let's dive into that. Just think about it for a moment. What is the common thread that connects a machine learning model that can write poetry, a financial system modeling market swings in real time, and a scientific simulation that can literally fold proteins? The thing is, they all need just a colossal amount of computing power. And there's a kind of secret engine making it all happen. Well, that engine, it's a technology called CUDA. Now, you might not have heard the name itself, but I guarantee you have seen what it can do. So what exactly is it? So, at its core, CUDA is this really revolutionary platform created by NVIDIA. It's basically the key that unlocks the incredible, untapped potential hidden inside of our graphics processing units, GPUs, and lets us use them for so much more than just making our video games look awesome. Probably the easiest way to wrap your head around it is to think of it like a translator. See, a developer writes code in a familiar language like C++. But the GPU, well, it has its own unique, highly specialized way of working. CUDA acts as this perfect bridge, translating the developer's instructions into a language that GPU can understand and execute at just mind-blowing speeds. Okay, so why is this such a game changer? Why is unlocking the GPU so important? To really get that, we need to look at what makes it so fundamentally different from a traditional CPU. And it all comes down to one thing, a superpower called parallelism. All right, here's my favorite analogy for this. Imagine your computer's main processor, the CPU, is like a brilliant world-class chef. It's incredibly smart and can handle very complex, sophisticated jobs, but it does them one after another, sequentially. The GPU, on the other hand, is like a massive army of thousands of prep cooks. Now, each one might only be doing a simple task like chopping one carrot, but they can all do it at the exact same time. And believe me, when I say an army, I am not exaggerating. While a CPU might have, say, a handful of really powerful cores, a modern GPU has literally thousands of them. This is its superpower, the ability to tackle thousands upon thousands of simple calculations all at once. That's what we call parallel processing. So the crucial point here is that it's not about one being better than the other, it's all about teamwork. CUDA enables something called heterogeneous computing, which I know sounds super technical, but it's really just a fancy way of saying you use the right tool for the right job. The CPU, our master chef, handles the complex sequential parts of a program, and then it offloads the massive, repetitive number crunching to the GPU army. Okay, so we've got this incredibly powerful hardware. How does a developer actually tap into all that power? You might be thinking, this sounds incredibly complicated. Is it some kind of dark art for coders? Well, thanks to CUDA, it's actually way more straightforward than you might think. NVIDIA has really boiled it down to 3 main steps. First, you install their CUDA Toolkit. Simple enough. Second, you write your code, and you identify the parts of your application that can be run in parallel by that massive army of GPU cores. And third, you use a special compiler to put it all together and run it. And this toolkit, it's not just a single program. Think of it more like a complete toolbox for developers. It comes with pre-written code and libraries for common tasks, the special compiler we just talked about, and even tools to help find bugs and really squeeze every last drop of performance out of their code. Okay, let's pull back from the technical details for a second. We've talked about the what and the how, but now let's talk about the why. Why should you care about any of this? Because this technology is a fundamental pillar of our modern world. I mean, just think about the fields this has completely revolutionized. Training the large language models that power things like ChatGPT, simulating weather patterns to predict climate change, discovering new drugs, analyzing financial markets. Every single one of these relies on processing just enormous amounts of data. See, at their core, a lot of these huge problems, they're actually millions of tiny, simple math problems that can all be solved at the same time. And that is the perfect job for a GPU. These were things that were once impossible or would have taken years. CUDA makes them possible in days, sometimes even hours. And really, that's the key thing to remember here. By creating that bridge to the GPU, CUDA didn't just make programs a little bit faster, it made the impossible possible. What it really did was democratize access to supercomputing power. It took it out of just the giant research labs and put it into the hands of researchers, engineers, and creators everywhere. And in doing that, it became this massive engine for innovation all over the world.
So, this all leaves us with a really fascinating question to chew on. For decades, a lot of our biggest ideas were limited by our ability to compute them. Now that barrier is just falling away, fast. So, when raw processing power is no longer the main obstacle, what are the incredible problems we're finally going to be able to solve? What's humanity's next giant leap forward going to be?